Alright, this video is about an introduction to complex numbers. In the Math 112 curriculum is when we're going to be talking about this, or pre-calculus curriculum. Complex numbers come into play pretty much when we start talking about them. Whenever you start talking about doing the square roots of negative numbers. Really, all numbers that we deal with are complex. It just so happens, though, we've never really in the past talked about the imaginary part of numbers. A complex number consists of two parts. The real part, represented by this letter A, and the imaginary part, represented by this BI part. I is what we call the imaginary unit, and I is the square root of -1. So anytime we have a negative underneath a radical, from now on we can actually simplify that expression using the fact that I is the square root of -1. Now if we talk about the powers of I squared, if the radical -1, square root of -1 times the square root of -1 would actually equal -1. And then I to the third would be -1 times I, so you get -I. I to the fourth would be +1 then. What you're going to deal with more than anything are these first two on the checklist, I and I squared. Those are the two we'll deal with more than the others. So let's play around with this a little bit to kind of get started. What we're going to use the I for. When you were talking in your earlier algebra classes, you were just told you were never allowed to have a negative underneath the radical. So if I had the square root of -49, normally we wouldn't be able to do that. But now that we know that the square, if you have a -1 underneath the radical, so we can think about this as the square root of -1 times 49. Well, we know now that the square root of -1 is an I, so we're just going to factor the I unit out. So take care of the -1 with the I, and the square root of 49. We know the square root of 49 is 7, so this is going to be 7I. Now that's a non-real answer. It's an imaginary answer. So you hear anybody talk about imaginary numbers? That imaginary numbers come into play whenever you have a negative underneath the square root. Let's try this next one, the square root of -84. So we're going to simplify the square root of 84 just like we always have, but we're just going to add the I to it because of the negative. So I will come out front, take care of the negative. So we have the square root of 84. So now I want to break down the square root of 84. So we need to find a perfect square, hopefully the largest one, that will divide 84. So right off the top of my head, 84 should be divisible by 4. 4 would go into 84 21 times. And I think that's about as good as we can do because 21 cannot be broken down into any perfect square factors. So the square root of the 4 can come out also. So 2I, the radical 21 will stay underneath the radical. So that's simplified as far as you can go with it. All right, look at the next example. 9 square roots of -40, same thing. The 9 is already out front, so I'm going to keep it out front. We're going to factor an I out to take care of the negative under the radical. And then I have the square root of +40. So then if I want to break that down or simplify that further, you have 9I. A perfect square that we know will go into 40 would be 4. So 4 times 10. 10, I don't think I can break that down any further. So that is correct. That's as much as we can do. So I can take out the, I've got the 9I already out front. Let's bring out the square root of the 4, which would be 2. And so I have radical 10 still underneath. So if we multiply those expressions out in front of the radical, 9I times 2, that would give me 18I square roots of 10 as my simplified version. All right, multiplying radicals, the same thing we've used in earlier algebra courses, same properties. As long as the items are both under radicals, they can be multiplied together. But we have to take into consideration that the I is going to be part of my answer here. So the square root of negative 7, I have to take care of the I part first. So I, bring that out, and I have radical 7. Okay, that's times radical, the square root of negative 10. Factor the I out there as well. So now we can simplify. I times I is I squared. And radical 7 times radical 10 will be radical 70, or the square root of 70. Now on the previous slide, I spoke to you about powers of I. I squared, you're going to always substitute in a negative 1. So I squared is negative 1. Anytime we see that, we're going to replace that. The square root of 70, I don't think I know a perfect square that will divide into 70. You could try 4, it won't work. 9 won't work. 16 won't go. 25 won't go. 36 won't go. So that's as far as you're going to be able to take that. 70s won't simplify anymore. So what we have here is the negative square root of 70 as our simplified version. So in this other example, the square root of negative 75 times the square root of 3. We're going to do the same process. I'm going to take the I out of the first radical, so square root of 75. And then that's times the square root of 3. Now I can try to simplify the square root of 5. Some of you may be seeing that and think 25 times 3 would work there. We could do that. Or we could just take it the way it is. I'm going to keep the I out front. Square root of 75 times 3. 75 times 3 is 225, which just happens to be a perfect square. The square root of 225 is 15, so we would get 15i. 15i for our product. Now, if you had done it the way I spoke about to start with, if we had said, okay, we have I, the square root of 75 would be 25 times 3. Then that's times the square root of 3. So we get I, the square root of 25. You guys remember that the square root of 3 times the square root of 3 is just going to be times 3. So we know the square root of 25 is 5. Then the 3, so that's going to still give us 15i either way. Okay, let's look at an example of division with complex numbers. We have to take the same consideration in this. If you have the negative under the radical, you have to factor the I out and work with it in that way. So in this problem, the square root of negative 72, I need to pull the I out. Okay, you have the square root of negative 6, so I'll have to factor the I out as well to get rid of the negative. Now, the i's will cancel out in division. I divided by I will cancel to 1. So in this problem, I actually have the square root of 72 over 6, which we know we can divide. 72 divided by 6 is 12. So to get my final answer, I need to simplify the square root of 12. We could break that down with this perfect square 4. 4 times 3, which will leave us 2 square roots of 3. And then the same thing on this last problem. The square root of negative 96, I'm going to factor the I out. That leaves me the 96. And then I have the square root of 2. There's no negative, so I don't have to factor an I out there. So the I is not going to cancel this time. So I have 1i. I have the 96 divided by 2. Those are both under radical, so I can do it that way. So that 96 divided by 2 is actually the square root of 48. So I have to think, how can I break up the square root of 48? So perfect square wise, 48 is divisible by 16. So 16 times 3 makes 48. So I can factor out the 16, bring it out as a 4, keep the I out front. The square root of 3 is still under the radical. All right, so hopefully this gives you an idea of what we're going to be dealing with when we talk about complex numbers have an imaginary part, and the imaginary part has the I involved. The I comes from the square root